In this video, I'll show you how to solve the ALEKS problem called identifying oxidized and reduced reactants in a metal-nonmetal reaction. So in this problem, you have three chemical reactions and you have to identify which reactant is being oxidized and which reactant is being reduced. Let's start with some definitions. Oxidation is the process involving the loss of electrons. And for this particular ALEKS problem, we can define oxidation as an atom or an element in its atomic state turning into a cation. A cation is something that is short or missing electrons due to the fact that it's lost electrons. The reduction process is the opposite. It is the gain of electrons. And for this particular ALEKS problem, we can define that as an atom or something in the atomic state turning into an anion. An anion is a negatively charged ion, and it's negative because it's gained extra electrons. Now, I do want to quickly point out that this definition that I'm giving here is accurate, but it is pretty limited. It really is going to work really well for reactions like this one, where we are starting with elements that are in their natural state. This definition is not always going to work for all oxidation reduction reactions because they're not always going to be of this format. So all that we have to do for this particular problem is take a look at what is happening to each one of these reactants. Specifically, are they becoming a cation or are they becoming an anion? Let's take a look at the first reaction. Here's zinc, and this is what zinc turns into throughout the course of the reaction. Now remember, when we write a formula for an ionic compound, we always write the cation first, followed by the anion. So the first substance in the atomic or in the ionic formula is the cation. So in this reaction, zinc has become a cation, which is defined as an oxidation process, the loss of electrons. ALEKS wants us to put in this box the reactant that was oxidized, and that is going to be the zinc reactant. So we're not going to put it in the ionic form, just zinc. Now, once we've identified one of these substances, for example, once we know what was oxidized, we just instantly know that the other substance is the thing that was reduced. And again, we're going to put the full form, I2, full form of the reactant in this box. Just to double check and make sure we understand what's going on. Here's I2, and here it is over in the product. Because it's second in the ionic formula, we know that it's an anion, and when something in the atomic state goes to an anion, that is a reduction. Let's do this one as well. Here is chlorine, and here's where chlorine ends up in the course of the reaction. It's second in the ionic formula, which means that it is the anion, and therefore it was reduced. And since we know it was reduced, then we know that the chromium was oxidized. And let's take a look at the last one. Here's nickel. Nickel ends up first in the ionic formula, which means that the nickel is a cation, and the other substance, the sulfur, S8, becomes the anion. So the nickel was oxidized and the sulfur was reduced.